Look at the slide, recovery of missing fundamental. So it takes, so how does it happen? What is the mechanism of this? It is not entirely clear. We don't know exactly how it is happening, but we know that it takes place somewhere in the brain, somewhere in the central auditory processing, somewhere in the CAP. Yet still the information from the periphery, from the cochlea, from the frequency resolution and so forth, that information is important. Another evidence that we know is even if so look at this next picture here. So this fundamental frequency 200 hertz is missing, component is missing, but 400, 600, 800, 1000 hertz tone components are there. So in that case, even when we mask out the 200 hertz region by just playing a lot of masker, so that even if there was a real tone, then it wouldn't be heard. Even in that case, what happens is even when there's a masker, completely masking out that frequency range, still we can hear that component of the tone. So this recovery of missing fundamental is pretty robust, and it's very reliable as long as the person has the frequency resolution that resolves 400, 600, 800, and 1000 hertz tones. So look at the next picture here. If the components are not in the harmonic structure, then basically there's no way for the brain to recover the missing fundamental frequency component here, because they are not in harmonic structure. In this example, 407, 630, 765, and 1000 hertz tone components, in that case, they are not in harmonic relation. Therefore, there's no fundamental frequency component to recover. So in that case, there's no pitch perception. There's no pitch we can associate easily. So next slide. So we are going to consider what really happens. What is the role of auditory filters? So here, actually, go back to the slide again. I just mentioned that the recovery of 200 hertz component is possible as long as the listener has the ability to resolve components, individual components, 400, 600, 800, and 1000, that are in harmonic relation. So in that case, I already mentioned that recovery of missing fundamental requires the listener to have the resolution of each component. Otherwise, it is not going to be possible. So, having said that, actually, this really directly tells us that auditory filters are important here, because remember when two tones or more tones are played together at the same time, do we resolve them? Do we process individual tones separately or not? That is very important matter. If we process them separately, or in other words, if these tones are resolved by two distinct auditory filters, then basically the brain receives individual information from each individual tone. However, if these tones are not resolved by distinct auditory filters, then it means that the brain is not able to find out what is what. Again, remember that? Two tones being resolved or not. Remember that? When they are resolved, that means that they are individually perceived, individually processed. When they are not resolved, then that means that they are not individually processed, individually perceived, but they are perceived as one chunk, one hodgepodge that is not clear. So whether the individual tones are resolved or not is going to be actually, there is a requirement for the recovery of missing fundamental. So go to the next slide here. So in the resolved case here, you look at this resolved case. So in that example, 200 hertz component is missing. So 400, 600, 800 are there. So you have this waveform here on top. That is really the combination of these three tones without fundamental component. So when we hear this tone, the way this tone is processed by the brain is the brain actually has three different components like that, 400, 600, 800, like that. The brain has that. Brain receives those components, and then based on those harmonic relations, the brain recovers the missing fundamental, which is 200. So this is the resolved case, okay? But next page, if you look at the unresolved case, in that example, we have three components again, but they are far higher frequency range, 4200, 4400, and 4600 hertz. So remember that. Around 4400 hertz. What is the bandwidth of auditory filter? About 4400 hertz. It's going to be about 600, 700-ish, okay? So these three components, 4200, 4400, 4600, are not going to be processed by distinct filters. And they are going to be just processed by one overlapping big filter. Therefore, when the brain receives this tone, when we hear this tone, as you can see this waveform, the brain does not resolve this into individual constituent components here. And brain just receives it as is, okay? So there's no way for the brain to recover fundamental frequency component, 200 components, based on this individual components. We cannot do that. The brain cannot do that. Then is the recovery of missing fundamental completely impossible? The answer is maybe possible, but it's going to be weak. The way it is possible is you can actually see this. If you look at this, you can still see 5 millisecond period or periodicity of the waveform. So remember, two mechanisms of pitch, place pitch and temporal periodicity pitch and place pitch. So in this case, if the auditory nerve or if the brain follows this periodicity of the waveform, which is 5 milliseconds, which corresponds to what? Corresponds to 1/5 millisecond. It corresponds to 200 hertz. So anyway, if the brain processes this on the basis of temporal periodicity, then brain can actually recover some component, somewhat of the 200 hertz component, purely based on temporal analysis, which is possible, but it is not going to be as robust as the earlier recovery mechanism based on individual harmonic relation. Okay. So there's resolved and unresolved cases. So again, this is another example where the understanding how auditory filters work is giving us good insight of how we handle the tones. Okay.